What's up, guys? I guess it started. All right. How was your day, everybody? Hopefully you've all seen the file I uploaded to the Google Drive about the two questions, right? So today, what we're gonna do is actually in two things. Firstly, discuss the problem questions that I uploaded yesterday, okay? So the problem questions about linear regression. And secondly, it's like question and answer. So if you got any other questions, just ask me, right? Because this is a last minute consultation, okay? Oh, it seems like only 5% is watching. Is it because everybody believe it starts at 8:30 instead of 8? Oh, Parsdallo said, "Hey Tony, I found some discrepancy in formula sheet posted on Canvas with lecture slides. Please confirm." So what is that? Oh my god, so many. Hypothesis testing for testing P1 minus P2, denominator should be P hat. Formula for exponential smoothing in time series should be t greater than equal to 2, not t greater or equal to... Wow. You pay so much attention to the details, right? It doesn't really matter because, well, let us discuss first about the testing on P1 minus P2 sort of stuff, okay? Okay, now, for hypothesis testing, actually there are two versions of the formula. So first of all, when you are testing if P1 equal P2, like P1 minus P2 equals 0 or not equal to 0 or greater than 0 or less than 0. So whenever it is 0, then what we need to do to build a test statistic Z is that, again, it's P1 hat minus P2 hat minus 0 definitely. But on the denominator, because we assume P1 equal P2. Therefore, even though you can observe a P1 hat and P2 hat, however, what we need to do is to combine those two P hats together. For example, if P1 hat equal to x1 divided by n1, x1 is the number of succeed or number of male or number of female, and n1 is the number is the sample size. And for P2, it's x2 over n2. So what we need to do here is to calculate P hat, which is given by x1 plus x2 divided by n1 plus n2. So this is like what we call a pooled estimate or pooled P hat, okay? So we need to put pooled P hat here times 1 minus P hat and then times 1 over n1 plus 1 over n2. So this is a specific case for P1 minus P2 equals 0. So other than that, what we need to do is, for example, P1 minus P2 equal to, for example, P0, and P0 is not equal to 0. So here, what we need to do is, alternative is something. And this Z is given by P1 hat minus P2 hat minus, for example, P0, and divided by, as usual, P1 hat times 1 minus P1 hat over n1 plus P2 hat times 1 minus P2 hat over n2, okay? It follows normal distribution. So those are the differences between those two test statistics, okay? So this is for P1 minus P2 equals 0. So if we assume P1 equal P2 under null hypothesis, then we need to use the pooled estimate of P hat and then plug in the formula. But if the difference is something, then we just use P1 hat and P2 hat over here, okay? Hopefully that answers your question, okay? And part style 2, I have noticed the same formula discrepancy in estimation as well for estimation of P1 minus P2. So if it is the estimation of P1 minus P2, I guess it's just P1 hat minus P2 hat plus or minus z half of alpha times square root of P1 hat times 1 minus P1 hat over N1 plus P2 hat 1 minus P2 hat over N2. So it doesn't matter if there is a P hat or not, because even if actually it should be P here, however, we don't have any, we don't have access to the population proportion, right? So instead, all we can use is just P1 hat or P2 hat, okay? All right, next one. In the formula for exponential smoothing in time series, it should be t greater or equal to 2 and not t greater or equal to 1. Okay, fine. Probably yes, so don't worry. Don't worry that much. Like if you can, if you can apply those formula, it doesn't really matter. Rotatosk is saying that, hello Tony, when you update tonight recording, otherwise I had to use 4G to see this live. I mean, this live streaming recording is automatically generated, so it's not, I cannot do anything about that. So probably after 2 hours, it will be uploaded, okay? Carrie Who is asking, what is standard error? Standard error, square root of, okay. Well, probably, I guess your standard error means in the what? In the linear regression analysis, under summary output, there is a standard error, right? And this standard error is actually called the standard error of estimation. So, this guy equal to the square root of MSE, or the square root of SSE over n minus k minus 1, okay? So this is the formula for the standard error of the estimation. It is actually sigma hat, it's sigma epsilon hat. So hopefully you all repember our epsilon follows a normal distribution with mean 0 and a variance of sigma epsilon square, the variance. So this standard error or square root of MSE is just an estimate of the population standard deviation, or population standard deviation of the error term. Okay. All right, next one. Can someone give me the link to the Google Drive for PLG for the question Tony mentioned at the beginning? It's actually in the in yesterday's recording under what? Under the description. So I can show you how to reach that. Oh wow! Look at where am I? Wow! Oh, this is ABS 4150. And let's see, how can we get to the questions? It's on the, where? Let me see. Yeah, it's on the live streaming consultation part 1. And down the bottom, okay, I think we need to go to my channel. And go to live streaming. Oh no, this is live streaming part 2, sorry. Live streaming part 1. So if you expand all, whoops, where is it? Refresh it. Okay, got it. So if you expand all, you can see under the live stream consultation part 1, we have please try the questions below, something, something. And here is the link to that question. And here are the quick links for the contents yesterday. Okay, so if you click the link, you will find the question I uploaded yesterday. Okay. Oh my God, is this answer your question? I hope so. All right, no problem. Let's go back and go back to our live streaming now. Okay. Now, next question. Please confirm whether shall we expect the correct formula sheet in final exam tomorrow. I have no idea, cause Ben is the only person who have access to the exam question formula sheet, so I don't really know what's going on in your final exam. But don't worry. I mean, I believe it won't affect your results. Okay. VN is asking, can you please demonstrate how to look up the critical values of the F distribution and which numbers to use for the numerator and denominator degrees of freedom? Thank you. Okay. Well, F distribution. I don't have an F table on hand, but the numerators degree freedom is generally the first degree freedom, and the second one is the second degree freedom. So I guess on the F table, for each column, it's for different numerator degree freedom, df, right? And for the denominator, it should be 1, 2, 3, 4 something. And F distribution, which number to use for numerator? Which number to use? It depends on what question are you asking. So, for example, if it is a linear regression problem, then the first degree freedom should the degree freedom of SSR, right, which is K, and the second one is n minus K minus 1. So if it is a restricted F test, the first one should be Q, and the second one is n minus K minus 1. Okay, so it depends. And for the table, critical values, so it should not be that hard. For example, this is a 5% like F table, and then you just find the degree freedom 1, degree freedom 2, and then find that value. Okay. So, Vibu Junja is asking, what is the difference between residual and standard residuals? All right. So, for the residual, oh, it's so low. I need to put it up a little bit. Okay. For residual, as we discussed yesterday, is the difference between the actual y and it's yi minus yi hat, right? So this is residual. So for standardized residual, they want to make the residual has a variance of 1 by dividing its for example, this is EI, okay, by dividing their standard error. So this standard error is actually calculated by that sigma error times some adjustment. So the formula is very complex, and it is in your lecture slide. I think here should be 1 plus something related to x bar or whatever. I can't remember exactly. But standard residual, it's just a standardized version of the residual, okay? What about yesterday's solution to questions? Shall we going to discuss today? Yes, that's what I'm planning to do. So, as I mentioned, you guys are all very in a hurry to go to the question and answer part. But as I mentioned, we need to talk about problem questions I uploaded yesterday. But now it seems like you don't have any other questions. So let's just go to see the questions that I uploaded yesterday. Okay, so let's look at why this bar is so high. No worries. Okay, let's go back and see the questions I uploaded yesterday. The first one is about the simple linear regression. It is saying that a young and aggressive investor plans to buy some BHB Billiton Limited shares or short-term investment. He will invest in the stock if the daily percentage return of BHB share price is higher than the daily percentage return of the All Ordinary Index. So here is a very important information. He says that he will invest in the stock if the daily return of BHP is higher than the market, right? So ordinary stands for the market, right? Okay, so he collects a daily percentage return of BHP and AORD, blah, 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 and uses a simple linear regression to help him to make a decision. He obtains the following results. All right, so this is plot, scatter plot, and summary output, right? Now, let's look at all the questions. Write down the simple linear regression model that this investor uses. So what do you think? When you are asked about the simple linear regression model, so what would you need to write? It should be percentage return of BHP equal beta 0 plus beta 1 percentage return of AORD plus epsilon. Is that right? So I believe many of you want to, look at the coefficients and then write down the estimated equation, right? So that's why I emphasized yesterday, you need to know if the question is asking you the regression model or the estimated equation, okay? So if it is a model, then you need to write down the model, all right? Now, second one, 3 marks. Test at a 5% level significance whether the regression coefficient beta 1 is greater than 1. Note that the critical value is 1.645. All right, so for this question, it actually belongs to the individual significance t-test, right? But for the individual significant t-test, the null hypothesis and alternative should be beta equals 0 or not. But now we want to know if the beta is greater than 1. Therefore, if you want to use this p-value or use this t-statistic directly, you will be wrong. Okay, so we need to work out this test manually. So how should we do that? First of all, let's think about the null hypothesis and alternative hypothesis. H0 should be beta 1 equal 1, and HA is beta 1 greater than 1, right? So it must be a one-tailed test instead of a two-tailed. And now, under null hypothesis, the test statistic is what? It should be the t statistic, right? So t star equal, it should be beta 1 hat minus 1 divided by the standard error of beta 1 hat. So where can we find the standard error of beta 1 hat? It is actually here. So I know it's sort of blur, but I can tell you the value, the standard error is 0.0321. So 0.0321. I know it follows a t distribution with n minus 2, right? because n minus 1 minus 1, because it is n minus k minus 1, right? So n minus 2 equal what? We can see the total observation is 252. So the degree freedom should be 250, right? 250. Therefore, let's state the decision rule. So at 5% level of significance, H0 is rejected if what? If the observed value of the test statistic is, no, not absolute value. This is only one tail test, right? So the observed value of the test statistic greater than the critical value, which is 250, 0.05, which is 1.645. Now let's calculate the results. The t observed value equal to beta 1 hat, which is 1.2992 minus 1 divided by 0.0321. And it equals, okay, let's quickly calculate it in your mind, okay? Quickly. Let's try who is faster. 1.2992 minus 1 divided by 0.0321. It should be 9 point something, 9.3, around 9.32, I guess. Okay, am I right? I don't know if I'm right because my brain is not functioning very well. Okay, great. Someone is saying 9.3209. Thank you very much. And it's obviously greater than 1.645. Therefore, H0 is rejected at 5% level of significance, and we can conclude that what? We have enough evidence to say that the coefficient beta 1 is greater than 1. Is that right? Okay, so this is just a full process of doing a hypothesis testing, right? Okay, someone is saying why it is 250, not 251, n minus 1? Okay, well, so for the if you watch the yesterday's video, it should be n minus k minus 1, right? And now k equal 1, so it's n minus 2. Okay, everyone is very clever. Thank you, Cliff Wei, and thank you, Rotas Tosk Wu. Thank you. All right, so that's all about the second question. You can see, sometimes we all know individual significance test, right? But when the question changes a little bit, it's gonna be testing on your understanding of the individual significance test. Okay, so yeah, it's not that hard, but if you don't understand what is the individual significance test, then you probably just have no idea about this, right? And thirdly, the third question is all about your understanding or your reading skills. So do you think that this investor will buy some BHP shares? So do you think the investor will buy? So let's go back and see. He will invest in the stock if the daily percentage return of the BHP share price is higher than the daily percentage return of AORD, which means if beta 1 is greater than 1, then he probably invest in these shares. Therefore, do you think the investor buy some share? Yes. Okay. Yes, he will, because you can say the reason because something is higher than the other thing, right? Okay. So definitely this investor will buy some PHP share. All right. So that's all about this simple linear regression question. And do you think it's easy or hard? Or easy or simple? Or hard or difficult? All right, that's fine. All right, that's all about question B. Now, let's go back and see the next question if you are happy with that. Question 4, 20 marks. A sales manager, okay, I want to have some water, is that okay? I'll go back very quickly in 1 minute because I sort of feel thirsty, okay? I see the wrong formula. Ha ha ha. All right. So you just read the question, okay? I'll get a cup of water. Hello everybody, I'm back. It is deceptive. Yeah, it is. All right, now let's look at question 4. A sales manager of BMW car dealer wants to study the relationship between the recommended retail price RRP of certain car, Y, and the specification of the car. The independent variables he considers are X1 engine size, X2 power, X3 transmission type, 0 for manual, 1 for auto, X4 series of vehicle. So now you need to pay attention to the series of vehicle because 1 stands for serial 1, 2 stands for 3, 3 stands for 5, 4 stands for 6, and 5 stands for 7. Okay, so if you probably make a mistake if you didn't pay attention. Okay. Someone is asking how much SSE can be considered as a large number. It doesn't really matter because SSE has their own units, right? Therefore, different number or different data has different magnitude, so we cannot conclude any SSE is larger or not. But if we compare it with SSR, we can actually build R square, which is SSR over SST, and see the percentage of SSR, which is just 1 minus the percentage of SSE, and then consider if SSE takes a lot of, is too large or not. Okay, so we cannot say if SSE is large or not, but simply based on the number. Okay, all right. Now let's go back to this question. He collects the relevant data from a random sample of 21 BMW cars and develops a multiple linear regression model to study the relationship. And the results is as follows. So firstly, write down this multiple linear regression model. Okay, multiple linear regression model. So what is that? We have 4 axes, right? Therefore, the regression model should be Y equal beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4 plus epsilon. Okay, so this is linear regression model. Okay, don't be cheated. It is asking you what is the model. All right, now secondly, write down the estimated linear regression equation. Okay, it is asking regression for manual transmission and automatic transmission BMW cars. Okay, so now for manual transmission and automatic transmission, it's actually determined by our X3 transmission types. 0 for manual, 1 for auto. Okay, so what we need to do is actually write down 2 regression equations one is x3 equals 0, the other is x3 equal 1. Okay, so for the manual one, let's see. For the manual transmission, the y hat equal to beta 0 hat. So let's see, beta 0 hat is minus 91.3449 plus x1 is 31.6130, x1 plus 0.2852, x2 plus x3 is 0, right? And x4 is 29 because this is dummy variable, right? This is just the base case of the dummy variable, 8859 x4. Okay, so this is the estimated linear regression equation for manual transmission cost. And for auto transmission cost, y hat should equal to what? So it should be a beta 0 hat plus this beta 3 hat, right? So let's merge them together and get minus 91.3449 minus 11.8153, we can get minus 103.1602, minus 103.1602. So the intercept term becomes minus 103.1602. If we add the intercept and when x3 equal to 1, it's minus 11.8153, right? And then plus the same thing, 31.6130 x1 plus 0.2852 x2 plus 29.8859 x4. Okay, so those are the two estimated linear regression equations for those two types of costs. Okay, now let's look at question 3. How much more do you expect to pay for automatic BMW than manual BMW of same specifications? Is this what you expect? Okay, so how much more do you expect to pay for automatic than a manual? So here is actually the interpretation of the coefficient of x3, right? So but before that, we need to look at the unit here in thousands of dollars, right? $1,000. So for all betas, it's all about thousands of dollars, okay? Therefore, how much more do you expect to pay for automatic BMW? It's actually minus $11,815.3 more than. So, or you can say 11 something thousand less than a manual, okay? So is this what you expect? Definitely not. From our common sense, do you think automatic car is more expensive or manual car is more expensive? Obviously, automatic BMW should be more expensive, okay? So it's not what we expect, okay? So you can answer no, this is not what we expect because from our common sense, automatic it should be more expensive than the manual one, right? Now, question 4. Show that the transmission type is not a significant factor in determining the RRP of BMW car. You must state the null and alternative hypothesis of the test. Use alpha equals 0.05. Note that t here is 2.12. Okay, we need to show the transmission type is not significant factor, which is x3, right? And here, look, the question leaves everything blank, so we need to calculate manually again. But now, when we are determining if the transmission type is significant or not, the null hypothesis and alternative hypothesis becomes beta 3 equals 0 and beta 3 not equals 0, right? So we're going to test on this one. Therefore, under null hypothesis, the test statistic is just t star equal, what is it? Beta 3 hat minus 0 divided by the standard error of beta 3 hat, which follows the t n minus k minus 1. So n minus k equal to 4. So n minus 4 minus 1, which is n minus 5. N here is 21. So 21 minus 5 is 16. Okay, so it's t 16. Now, H0 is rejected at 5% level of significance, H0 is rejected if what? If alpha is 0.05, we can simply use this rejection region approach, which is the observed value, T observed value, absolute value greater than the T16 0.025, okay? And now the T observed is calculated to be, let's see, it's minus 11.8153, or the absolute value. And the standard error here, let's see, standard error is 12.5560, 12.5560, and the final result is 0.9 something, right? Let's see, 11.8153 divided by 12.5560, and it's finally 0.9410, 0.9410, and it's definitely less than 2.12, right? And it tells us the critical value is 2.12. Or you can just go to the table and calculate the result. Therefore, H0 is not rejected at a 5% level of significance, and therefore, which one is not? Transmission type is not a significant factor in determining the RRP of BMW car. So you can say, therefore, transmission type is not an important factor or significant factor in determining the RRP of BMW car. Okay, so just draw the conclusion. Answer what you are asked. Okay. All right. So this is the first 4 questions. Let's see so far. Do you have any questions? Let's see. Trista Lee is asking, since the PPT in week 10 says that the basic criteria for assessing model fit, if SSE and SE is small and R square is close to 1, the model fit is good. Yes, it is. SSE and SE is small. We need to compare it with, for example, with the magnitude or the average of y, for example, okay? So let's go back and answer the question of this student, okay? So first of all, for SSE and standard error, we know that this standard error is actually the square root of MSE, and it's actually square root of SSE divided by n minus k minus 1. Therefore, when you answer SSE or SE, you just say the same thing, okay? But just in a different magnitude. So for SE, standard error, we generally compare it with our y bar, okay? And see how many percentage of that takes in the y bar. So for example, if your data is around 1,000 something, okay, as a y bar, then 10, standard error of 10 is not a large number, right? However, if your y bar is around just 1 something, then 10 will be a very large discrepancy, is that right? So it depends. It depends on the magnitude of your data. And also, R square is another good measurement of seeing if SSE is large or not, right? So if R square is close to 1, this means SSE is very small, is that right? Compared to SSR, okay? So hopefully this answers your concern. All right, so it's all about understanding, and there is no strict rules in if SSE or standard error is small or large. It's all about your comparison and your professional judgment, okay? And Shuai Liu is asking, sorry to bother you for this regression model. Do we need to replace x2 or x3 by power, or just use x2 to represent the power and something else? I notice it's different from the first question. What do you mean? Well, yeah, x2 is just power. x2 is power, right? x3 is transmission type. So is there any question? Okay. Okay, because I know what your question is. Because in the first question we use the percentage return. That's because we haven't defined x1, x2, x3, x4, right? But in this question, they've already defined all those y's and x's already, so you can directly use x1, x2, x3, and x4. Okay. So in the last question, if you do define those variables by yourself, for example, denote y as the return of BHP and x as return of AORD, then you can write y and x over here. Okay, so it's just about if you have defined all the independent variables and dependent variables. Okay, so it doesn't really matter. All right, now that's all about the first part of question 4, but it's not yet come to an end. Let's see the second half of this question. Now, the sales manager now believes that there is something wrong with his analysis, and he consults a business analyst. Yeah, the business analyst suggests him to suggest somebody using, right? Oh my God. Using a stepwise regression. Okay, you haven't learned stepwise regression, but it's just like getting the best result, okay? To choose the best subset of independent variables. The sales manager takes his advice and finds the following new results. Okay. Okay, this is a new result. In this question, we can see only x1 and x4 is included. This means we remove x2 and x3. Is that right? Okay. Now, question 5. Interpret both the p-value in the overall significant test of the regression model and p-values in the individual significance of the regression coefficient. Use alpha equals 0.05. So, as we can see, it's only worth 2 marks, so it's not asking us to perform a whole or full process of hypothesis testing, right? So, for the p-value of significance, for the overall significance, this p-value is equal to 0.000. Is that right? And it's definitely less than 0.05. So the model is overall significant, right? The model is overall significant. And for each individual significance, all the p-values all equal to 0.000 for any of the coefficients, right? This means that every independent variable, every coefficient is significant, okay? So every coefficient or independent variable is significant. Okay, it's all about your understanding of the overall significance test and individual significance test, okay? So as long as you express this idea of p-value less than alpha, we reject null hypothesis, for example, and then they are significant, okay? That's fine. Now, question 6. Question 6 is asking interpret the regression coefficient of x1. Okay, so let's do it. X1 has a coefficient of 49.31, but you need to pay attention. 49.31 should be in the unit of thousands of dollars, right? So it should be 49,000. 49,000. Yeah, it should be like this, right? Therefore, for the coefficient interpretation, I guess you all done that in your major assignment or group assignment, right? So 2 key things. One is that keeping all other variables constant, right? Keep all other variables constant. If let's see what's the meaning of x1, okay? X1 is engine size, right? Therefore, we need to say that if the engine size increase by 1 liter, then on average, right? The second important thing is on average. One is on average, the other keep all other variable constant. On average, the RRP of a BMW car will increase by $49,310. Is that right? Okay, so this is very simple. And it only worth 1 mark, right? Interpret the regression coefficient. Now, question number 7. It is asking us find the estimate of error standard deviation. So the standard deviation of the error term and the estimate of it. And we know that the error term follows a normal distribution with mean 0 and variance of sigma epsilon square, right? And so the standard deviation of the error term should be sigma epsilon. Therefore, what we need to find is an estimate. It's asking us to find the estimate of error standard deviation. So what is the estimate? It's just a sigma epsilon hat, which is the square root of MSE, right? Or you can just find it on standard error here, but obviously it's not here. It's blank. So we need to find MSE by ourselves, which is over here, right? So MSE is here, 386.97, so we just take a square root of it, 386.97, and we can get the results. So square root of 386.97, it's finally 19.67, okay, 19.67. So we can just 19.67 over here, okay? So the estimate of error standard deviation sigma epsilon hat is equal to square root of MSE, and it is just the standard error, okay? Now, question number 8. Show that R squared is 0.9652 and hence find the correlation between y and y hat, okay? So for this question, we know from yesterday, we've discussed a similar we've discussed the knowledge about whole bunch of r's, do you remember? So show that r squared. So r squared should equal what? SSR divided by SST, is that right? So let's find SSR. SSR is 193282.05, but the problem is we don't have SSE and SST, so we need to find all of them up. What we have here are the mean squares, MSR and MSE. So first of all, the easiest thing that we can do is the degree of freedom. The regression degree of freedom is actually number of independent variable, which is k. So in this question, only 2 independent variables, it should be 2, right? And for the residual, it should be 18, isn't it? Okay. So we got mean square, or MSE, we got the degree of freedom, so we can definitely got SSE by multiplying 18 on 386.97, right? So we use 18 times 386.97, and it's 6965.6446, 6965.46, and we added it up with 193,282.05, we got SST, which is 200,247.51. So 200,247.51. Okay, this is SST. Therefore, R squared is just given by 193,282.05 divided by 200,247.51, and the final result should be 193,282.05 divided by the answer. It's 0.9652. Is it? 9652. Brilliant. 0.9652. Awesome. So find the correlation between y and y hat. We know that correlation between y and y hat should be the square root of r squared. I don't think you've learned this in QBUS5002, but it doesn't matter. It's like it won't hurt, right? It's multiple r, therefore it's square root of 0.9652, which is square root of it. It's 0.9825. 0.9825. Therefore, in the first two blanks, you can actually fill them all out. For r squared, it's 0.9652, and multiple r is simply 0.9825. Okay, so it's just square root of r squared, which is multiple r. All right. Okay, so that's all about question 8. Now question 9. Oh, it's obviously a prediction question, right? It says BMW is going to launch a new 3 Series sedan car with automatic transmission. 3 Series. The engine size is 2.2 liters and power is 135 kW. So what RRP of this car will the sales manager predict? So guys, which of the prediction model shall we use? The original model or the new model? We shall use the new model, right? Okay, so for the new model, is actually y hat equals minus, let's see, it's minus 102.2. 102.2 plus 49.31 x1 plus 3127 plus 3127 x4. Therefore, we only have x1, x4 over here. So x1 is the engine size, which is 2.2 liters in this question, 2.2. And for x4, where is x4? X4 should be the 3 Series car, right? But we need to pay attention. What is the value of x4 if the series is number 3? Let's go back and see. For series 3, it should be 2, right? So 2 stands for series 3, okay? So 2 stands for series 3. Okay, so we need to plug in 2 over here instead of 3, okay? All right, now let's do the calculation together. It's minus 102.2 plus 49.31 times 2.2 plus 31.27 times 2, which is 68822. 68.822 thousands of dollars. Or you can say it's just 68822,000 of dollars. Okay, so you need to really pay attention on the unit of your data. Okay, and try to have it make sense. Okay, because in your midterm math exam, many of you has deducted 0.5 mark because you didn't include a dollar sign in front of your result. Okay, that's not good, right? Okay, now question 10. Perform a formal statistical test to show that the full model in 1 can be reduced to the model suggested by the stepwise regression technique. You must state the full and alternative hypothesis, calculate the value of the tested, and draw a conclusion based on alpha equals 0.05. And the F value is given here. All right. Okay. So for this question, we know it's all about the restricted F test, right? Because we want to know if the restriction is valid. So let's see, which are the 2 variables that we remove from the original model or the full model? It's x2 and x3, right? Okay, so for the restricted F test, what we're going to do for this question is null hypothesis alternative. So null hypothesis should be all the beta that we removed are equal 0, right? So x2, x3, so it should be beta 2 equal beta 3 equals 0. And H1 should be at least one of the beta 2 and beta 3 is not 0 or non-zero. Is that right? So this is the null hypothesis and alternative hypothesis of the restricted F test. So under null hypothesis, the test statistic is what? is our F statistic, which is given by SSE unrestricted or restricted. It should be which one has a larger error. Larger error should be restricted model, right? So SSER minus SSEU divided by Q. So Q should equal to 2 because we removed 2 independent variables. And then divided by SSEU over n minus k minus 1. So n minus k. In our first model, k equal 4, right? So k should equal to 4 in the first model, because this is for unrestricted model. So it should be n minus k minus 1. And we know kn equal something here. Well, just forget it a little bit. And it follows of F distribution. And this F distribution has a degree freedom 2 and n minus k minus 1. So let's see, n is 21, k is 4. So 21 minus 5 is 16. So it should be 16. I'll just write 16 over here, okay? All right, so this is the test statistic. So the decision rule will be H0, okay, at 5% level of significance. H0 is rejected if what? If the observed F is greater than the critical value 216 0.05, right? And we know this value equal to it's given 3.63, right? 3.63. 3.63, okay? So now let's calculate the observed F. The observed F is what is the SSE of the restricted model? Let's find it out. Where is the restricted model? Restricted model here. Okay, for the restricted model, the SSE is 6965.46. So 6965.46 and minus full model. Full model is 5716.74. So 5716.74 divided by 2, and then divided by the SSE of the full model, which is the 57. Okay, actually on the denominator it's just MSE, right? So it's 357.3. 357.3, because this guy is just MSE of the unrestricted model, right? All right, and let's calculate this result. 6965.46 minus 5716.74 equal, and then divided by 2. It's 624.36. 624.36 divided by 357.3 divided by 357.3 is 1.7474. 1.7474. All right, and this value is obviously less than 3.63. Therefore H0 is is not rejected at 5% level of significance. And we can conclude that, let's see, we can conclude what? How full model can be reduced to the model. Okay, it can be reduced, right? So the restriction is valid, right? Therefore, and the restriction is valid. Beautiful. This means beta 2 and beta 3, we cannot reject, they are equal to 0, right? So it's valid. Okay, that's all about this question. So do you think it's easy or simple? Okay, easy, right? Or simple. So it's not that hard once you know everything about the knowledge, okay? I'm not saying that your final exam will be similar as this one, because this one is just for practice purposes, okay? Just for you to get some practice. So for final exam, it can be very different, but if you really understand what's going on here, then there shouldn't be any problem. Okay, moderate, brilliant. That's a good word. Well, let's now collect some questions from students now. So Vn, when we write the model, do we need to write I1 etc. or D1 for dummy variables? Well, yes, you can. But in this question, they just use X3, so you just use X3. It doesn't matter, okay? But to be more, specific, it's better to use D3 instead of X3, right? Based on what you learn. So it doesn't matter. How many decimals should we reserve in the test? 2 or 4? I think 4 is better, okay? You better use 4 decimal places, okay? Model is not useful, okay. 1.75, good, yep. Olivia Lee is asking, do we need to test the overall significance for the full model? It's not asking us, so we don't need to do that, right? It's just asking us to perform if the restriction is valid or not, right? Because in this, okay, no. Let's see in the first part. No, it's not asking us the overall significance of the full model, so you don't need to answer that, right? Okay, Olivia Lee is asking, there are 2 formulas on the formula sheet for testing exclusion restrictions and testing overall significance. What's the difference? What do you mean? There are 2 formulas on the formula sheet for testing exclusion restrictions and testing overall significance. Okay, they are different tests, right? Overall significance test is testing the overall significance of the model, but the restricted, like exclusion restriction test is testing whether or not we should remove some independent variables. So they are just different tests, right? Okay, you wanna why? Okay, i.e., why can't we just use F value on the ANOVA test to test overall? Yes, we can. Yes, we can. Yeah, this is overall significance test, right? But in this question, it's asking us the reduced model suggests, okay, whether or not this restriction is valid. So this is the time that we use partial F test or restricted F test. Okay. So any other questions? Probably not about this problem, but any other questions related to final exams. Like we finished the first part of today's online consultation, which is the the problem question, right? And then now it's a time for question and answer. Okay, Jenny Eugene Wu is asking, could you make H0 and H1 for the statement? The true mean number of months families in the city have been living in their current home is at least 30 months. Okay, the true mean. All right, so thank you very much, Jenny. Can everyone see Jenny's question now? Yeah, okay. So here for Jenny's question, the true mean number of months. Therefore, we can just let mu be the mean of the month that something, right? So the null hypothesis will be mu equal 30 and H1. Let's see. It is testing at least 30. So at least 30 means greater or equal to 30, right? So if we want to test greater or equal 30, then the alternative hypothesis should be less 30, okay? So if H1 is not, if we reject H0, this means mu is less than 30. So it's not greater or it's not at least 30. If we do not reject null hypothesis, then it's at least 30, okay? So this is, I know this is a little bit tricky, but hopefully you understand. All right. Vibu is asking, can we discuss? I know you asked this question yesterday. Stratified sample mean and variance of the stratified sample. You know what? it seems like on your PowerPoint slides, Burn did not really include week 6 contents, right? So I'm not quite sure. Stratify sample. Okay, fine. Let's go back to the lecture slides and see, okay? Because I'm not quite sure about that. I haven't learned that before. I'll go to the canvas if all of you have this problem. Stratified. It should be in week 6, right? I'm going to week 6. Sampling strategies, week 6 PDF. Stratified sample mean. Sampling method. Stratified. Okay, stratified. So you know what? This is a kind of topic that every time I learn it, read it, I understand. And after 1 month, I forget it. It's really, really bad. Random sampling topic, systematic. Well, let's look at the lecture slides together. Systematic sampling, stratified sampling. Okay. Stratified sampling entails a subdivision of the population into subpopulations or strata. Strata is plural, stratum is singular. Okay, from each stratum, successive samples are drawn, and each stratum is treated as independent. Natural strata already identified in the accounts include geography, for example, Melbourne, Brisbane, Sydney, different branches, factories, product differentiation, etc. The aim is to first obtain statistics for each stratum and then combine. I got it. Okay. So let's see the calculation. Okay. Where are the calculations? The advantage, so many advantages. Draw samples according to sampling method, judgment random systematic, and estimate sample statistics for each stratum individually as if each stratum is independent population. Okay, so here is very important, independent population. So we can directly, calculate, add up all their variances, I guess. Combine individual stratum information into information about the entire population by weighing the information relative to the size of each stratum. Okay, good, beautiful. So stratified sampling notation. So strata, we have different stratums, 1 to m, and population item xi. Okay, total population is all right, good. The sample from stratum is okay, I sample, right? IM, okay. Sampled items for the stratum is X1M, X2M. All right, sampled items. So estimating the population mean. To estimate the overall population mean mu, for stratified sample, we use X bar S. So do you understand this? All right, so for the stratified sample mean is just a weighted average of all sample means, right? I'll give you an example later on. Let me learn it first, okay? Let me learn it first. I can came up with an example and let's discuss it together. So it's just a weighted average of the sample means. Let's look at variance. So for variance, it's just a weighted average of, let's see, this is strata's proportion and this is strata's variance divided by its sample size. Okay. Oh, this is the variance of X bar. This is like X bar's variance. So we are looking at the sampling distribution of X bar. Okay. So we must estimate sigma m with SM, the stratum sample standard deviation. Okay. So XIM, XM square. So this is the sample standard deviation for each sample. And okay, this gives variance of this to be this. And standard error is this bad boy, yes. the contribution of each stratum to the overall variance of the stratified. Okay, all right, this is how they contribute. And we can write this strata example. All right, so we finished learning everything. Okay, now let's see if you still have any problem. And then I'll give you stratify. Let me go back and check your chat history. Sample mean and variance. Yes, yeah, the stratifying formula. Yes, weeks will be the final exam. Cheers, burn posted on ED. How can we use okay, good. So no problem. Let's just think about the example. Okay. So let's start from a stratified sample. Okay, so I just learned it. If I'm wrong, just let me know. Okay. So first of all, a stratified sampling strategy is actually to divide our population in different groups based on their nature properties. For example, if what can we do? Okay, so if I want to collect the average mark or average mark of the mid-semester exam of all students, is that okay? So we have three streams: stream 1, stream 2, and stream 3. So for example, stream 1 has total number of 100 students, and stream 2 has 40 students, and stream 3 has how many? What do you think? How many students? Okay, let's make it 60. So stream 3 can have 80 students because we have exactly 240 students in total as a population. Okay. So if we want to have average mark to be surveyed, one good strategy is to ask a certain proportion of students in each stream and calculate their sample mean. So for example, for stream 1, I collect, based on their proportion, I collect, for example, 30 students as a sample. Okay, so N1 equals 30. And then N2 must be proportionally, N2 should be, for example, 18 students, okay? And for stream 3, N3 is 24 students, for example. And my observed X1 bar, X2 bar, and X3 bar are actually equal what? Not what, I'll tell you, okay? Let's just make up some number. X1 bar is observed to be 66, and this is 64, and this is 65. Is that okay? So those are the average marks of each stream. Okay, now what I want to do is to make a overall estimation of the average mid-semester mark of the whole population in QBUS5002. Okay. Whole population of QBUS5002. Therefore, in order to calculate, to estimate this grand mean mu, what we need to do is to calculate a grand X bar, right? So how can we apply this X bar? So we can see the whole population size here is what? It's 240, right? And we break it down into three different populations. N1 is 100, N2 is 60, N3 is 80. Is that right? So for X bar, overall X bar is simply the weighted average of all of those. Okay, weighted average of all of those. So what do we mean by that? The weighted average is that we use, for example, for sample mean 1, X1 bar, then divided by 240 times 100. Okay. And plus X2 bar times 60 divided by 240, plus X3 bar times 80 divided by 240. So those proportions are just based on the weight of the population things, okay? So Actually, it makes sense, right? Because stream 1 has 100 students, which is more representative, so we need to put more weight on stream 1. And for stream 2, probably less students, so less weight. Stream 3, moderate students, so moderate weight, okay? So after that, the whole sample mean is calculated to be well, just do it, 66 times 100 over 240 plus 64 times 60 over 240 plus 65 times 80 over 240, which is 65.17, right? So 65.1667, something like that. So the average mark is for the whole QBUS5002 student is actually 65.1667, right? Now, I think this is very easy, right? But the problem is, if we want to create a confidence interval on the mu, what should we do? It should be x bar plus or minus something, for example, t, okay? T some value times the standard error of x bar. Is that right? So we need to know what the standard error is for x bar, right? So based on central limit theorem, what do you think is the standard error of the stream 1's x bar? What's the standard error? It should be sigma 1 over n1, or sigma 1 squared over n1. And the second one should be sigma 2 squared over n2, right? The third one is sigma 3 squared over n3. Is that right? Okay. So this is first one, second one, third one. This is the variance of x bar based on central limit theorem. Can you all catch up? Yes? Is that right? Based on central limit theorem, or just, well, this sample size is not large, but just suppose that the marks are normally distributed, okay? So the marks are normally distributed, so they follow some normal distribution, and mean is just the mu, and the variance is just sigma divided by n, right? So for each sample, for each population of each stratum, the variance is like this, right? So if we combined, we know x bar is combined by the weighted average of each sample. Is that right? Therefore, the variance of x bar should also be the squared weighted average of each of each variance of x bars. Okay, so this means we use what kind of proportion? It should be nm. Nm stands for the number of strata, and this is the total number of n. And we use the square of it to put to put on the weights, okay? And times the sigma m. Sigma m stands for the variance of each population, okay? Square divided by nm. Nm stands for the sample size of n, okay? And we get a sum of it, m from 1 to 3. So this is exactly your formula, I guess. Am I right? I'm not sure. I just read it once, so I guess it's right, okay? I guess it's right because it makes sense. So in applying this formula, let's do it together. So firstly, this proportion is 100 divided by 240 square times sigma 1 square over n1. n1 is 30. Plus, second one, 60 over 240 square times sigma 2 square divided by 18. Is that right? Plus, last one, 80 over 240 square times sigma 3 square divided by 24. Okay, now the problem is, are those sigmas known or not? They are unknown, right? So what should we do? We calculate the sample standard deviation or sample variance, right? So let's assume the sample variances are SMs, okay? So for SMs, this is S1, this is S2, this is S3. So probably you can simply, I guess if there are any questions in your final exam, all those S should be given, okay? So we substitute all those sigmas by S1 square, S2 square, and S3 square, okay? And if all those S are observed to be some number, okay, and then you can just plug in the number and calculate the result. I don't want to press the formula. I don't want to press my calculators now, okay? It's not that hard. So after that, we calculate variance of X bar. For example, let's suppose a number, okay? Suppose that the variance of the mark is, for example, is 225, okay? Let's suppose it's 225, is that okay? So if it is 225, we know the standard error of X bar will be what? The square root of what? Okay, variance of X bar is too large, I think. Not 225. Let's try. If it is over 240, square root of it. Let's suppose the variance is just 4, okay? The variance is just 4, all right? So if the variance is 4, then the standard error should be 2. So standard error of X bar is 2. Therefore, if you want to build a confidence interval, you can use the X bar you calculated, which is 65.1667, and plus or minus some t distribution. So t should be t half an alpha n minus 1. For example, this is 2.00 something, okay? Suppose the t equal to 2 and times the standard error 2. So it's the mean, then the true population mean will fall between 61.1667 to 69.1667. So this is the confidence. This is the confidence interval for the average mark. Okay, so yeah, that's for the whole area. Okay, that's all about the stratified sampling. It's nothing but we just divide all the population into different groups, and we use the mean. We calculate the sample mean to. We use the weighted average sample mean to get the whole sample mean, and for the variance of the sample mean, we use the squared weighted average of each for each variance of X bar, and then we can do any estimations, okay? So that's all about the stratified sampling. So I just learned it, so if I'm wrong, just let me know, but I don't think I'm wrong. I'm always very confident of myself, okay? Even though I just learned it, but all right, sorry. Okay, well, let's see more questions, okay? Okay, Jia Wei Yuan is asking, how can we use MAD and SSFE in time series analysis? So MAD and SSFE are just two criteria, like R square and significance F. They're just measuring the fitness of the model or how good the model is. So MAD, I think it should be the lower the better, and SSFE is, I'm not sure. Let me have a look at on the week 12, okay, material. Week 12 is week 12. Oh no, week 12 is ratio. It should be week 11, right? Let's see, week 11. Week 11 is SSFE time series. Okay, well, let's see. MAD is, look, this is like residual, right? So residual absolute value, average residual absolute value sum, and this one is just residual square sum, and this is just SSE, is that right? So the lower the better. For example, if you got 2 time series models, one has an MAD of 10, the other have 12, then 10 one is better. SSFE, one has 100, the other have 144, then the 100 is better. So it's just a criteria on the model selection, okay? So look, predictive ability of competing models. Okay, if we have two models, we can use MAD and see if one model is better than the other, okay? But I don't think it's going to be tested in this unit study because it will be heavily used in advanced course, okay? Like QBUS5002, something like that, okay? Like more advanced time series, right? All right, hopefully that answers your question. Okay, any other questions? Let's look at the questions. If those formulas from week 6 would be provided in the exam, yes, they are. Bottom of the inference page. Good. Thanks, Tony. I see. Thank you. Got it, Tony. Thanks a lot. Week 11. VN. I know you already covered this, but could you please show again the values on the Excel output you use to calculate SST? What do you mean? Do you mean the question we discussed just now? SST. Okay. SST is simply SSR plus SSE. So you need to remember SSR plus SSE equal SST. Okay. So we got SSR over here, SSE over here, and then add them all together, we can get SST. Okay. And if you want to know how to calculate SSE, we also have the relation that MSE equal SSE divided by n minus k minus 1, which is the degree freedom here, 18. Therefore, if you're going to want to get SSE, it's simply MSE times 18. So 18 times 386.97, you can get SSE, okay? So the damn dragon glass. Okay, the damn dragon glass is asking, going back to the regression question 8, what is the correlation between y and y hat? Okay, so you don't need to, actually you haven't learned this in QBUS5002 because this is a QBUS5001 exam paper and in 2012. But correlation between y and y hat is simply the square root of r square, okay? It's the square root of r square, or what we call the multiple r over here, okay? The multiple r. Is the significance f, Doris Y is asking, is the significance, this is significance f, I guess, the p-value of the overall significance? Yes, it is. This is the p-value of the overall significance f test, okay? How can we calculate y bar in regression? You can only calculate y bar if you get the source data, but in this question, we don't have access to, we can. Yeah, let's see if we can calculate y bar. So this is SST. No, we can't. No, we cannot calculate y bar. We can't calculate y bar. Any other questions about anything? Oh, let me have a cup of water. Okay, this is water, right? Do you have any other questions? Come on, more questions. Come on. Yeah, thank you, Bert. Alcohol inside? No alcohol, come on. What's the formula to calculate y bar? Oh, come on. Formula for y bar, it's, hey, are you kidding me? Y, it's just average of y. So you add all y together, divided by the number of observations. So this is how you calculate y bar. Okay? So Pars Dalla is asking, what about theory questions? Okay, for theory questions, I mean, it's all about your understanding. Like, I know you're all very good at calculation, but for example, what I introduced yesterday, if you remember, involves a lot of understanding. Is that right? So, for example, in your calculation, they probably asking you what is calculate the standard error of x1 bar minus x2 bar. Calculate the standard error of x1 bar minus x2 bar. So what would you do? They are not asking you to calculate a confidence interval, right? They just want you to calculate standard error. So you need to know how x1 bar and x minus x2 bar is distributed. So we know based on central limit theorem, it's normally distributed with a mean of mu1 minus mu2 and variance of sigma 1 squared over n1 plus sigma 2 squared over n2. Is that right? Therefore, the standard error should be square root of sigma 1 squared over n1 plus sigma 2 squared over n2. So this is just a simple calculation, right? But if you don't understand what is the standard error of x1 bar minus x2 bar, but you only know the confidence interval is calculated by something like this, square root of sigma 1 squared n1 plus sigma 2 squared n2, then you only know how to calculate that, then you probably have no idea of this calculation. But this calculation is actually much easier than the calculation of confidence interval, right? So yeah, that's what I mean. Like for theory problem, it's all about your understanding of the concepts, okay? All right, the damn dragon glass is asking the standard error over y%. What is that for again? Okay, well, it's just a relative comparison to determine if the standard error is large or not large, okay? So if y bar is around, for example, 100, and we have a standard error of 1, then this standard error will be very, very small, right? But if y bar is equal to 0.1, then we have a standard error of 1, then this will make a significant difference in our prediction, right? So it's not a formula, it's just it's from my experience. If I have a standard error, I would generally compare it with the magnitude of the data, okay? So just like you want to compare, for example, some standard deviation of two groups. One group is 100 and the other group is 200. I mean the standard deviation. S1 is 100, S2 is 200. So can we say that the second group has more variations or more spread out or more deviations from the first group? Not really, because we need to see the magnitude of those two data, right? So for example, if the mean of the first one, x bar of the first one is 10,000 and x bar of the second one is 1,000. Is that okay? So, 1 million. Is this 1 million? Yeah, 1 million. Okay, so by using the standard deviation divided by the mean, we actually calculate the coefficient of variation, right? CV. So coefficient of variation, this one is 1%, and this one is, you know, is 0.02%. So this one is much more varies more from their means compared to this one. Okay, so it's all about the comparison of the standard deviations. Okay, any other questions? Hopefully it makes sense for you. But I feel so hungry. Any other questions? Any other questions, guys? Crystal Who, can you talk about the MCQ part? Well, what do you want me to talk about multiple choice question? Just because I have no idea about what's going on in your final exam. The only person who have seen your final exam is Bern. So I cannot give you any like instructions of your multiple choice question, but just take it easy. It won't hurt, okay? If you know every single knowledge and understand everything, then the multiple choice question won't be very hard for you, okay? So can you just a bit confused with slope coefficient formula? Okay, I know you are confused, but don't worry. It won't be tested. I mean the slope coefficient. All set, have your Dana. Bye, thanks again. Thank you so much for your time. You have really been valuable. Could you please explain the dummy variable traps? What is dummy variable traps? Hey guys, is there any traps on the dummy variables? Okay, that's interesting. Let me have a look at the dummy variable traps. Dummy variable traps. Okay. Look, by searching on Google, it says dummy variable trap is a scenario in which the independent variables are multicollinear, a scenario in which two or more variables are highly correlated. In simple terms, one variable can be predicted from the others. To demonstrate the dummy variable trap, take a case of gender as an example. Okay, what's the example? Let's read it together. So if you're confused of anything, you can just go to let's take this thing, okay? Okay, all right. Let me read it and then I'll give you my answer. Okay. Okay, good. So for dummy variable trap, this dummy variable trap will happen if one or more dummy variables have perfect linear correlation with each other. For example, if you include in your model a male dummy variable, D1 as 1 equal to male, to 0 for female, and then you have another one, 1 for female and 0 for male, then those two dummy variables are perfectly linear correlated, and this is called the dummy variable trap. So this one is obvious, but I guess there should be other traps that are not that obvious. For example, if we have 4 seasons, spring, summer, autumn, winter, so D1, D2, D3, D4. So for example, D1 is for spring, and D2 is for summer, and this is for fall, and this is for winter. So seemingly they are not intercorrelated with each other, right? However, if all D1, D2, D3 equals 0, it's exactly winter. Is that right? So all of them have sort of correlation with each other. That is what we call a trap, a dummy variable trap. So how do we deal with this trap is to make the number of dummy variables to be the number of categories. For example, if we have k-tech categories and then -1, right? So if we have 4 categories for the seasons, then we just use 3 is enough. And the other one is when all the other dummy variables equal 0, and then it's the last category. So that's what I am understanding so far when I first read from the website. Okay, so actually for this kind of concept question, it's easy to get your solutions if you search it online and do your readings by yourselves, right? Okay, any other questions? How to interpret the base case when there are more than 1 dummy variables? Okay, good. Well, let's continue this example. If there are more than 1 dummy variables, the base case is, this is when in winter, right? So this is just the winter's, for example, prediction equation, something like that, right? Okay, Vibu is talking about dummy variable trap is when you have 4 dummies, you just take 3, and if all 3 are 0, then the fourth one is the answer. In short, don't include all 4 because it will be a trap. Oh, wow, thank you, Vibu. It seems like we have the same idea, right? Thank you, thank you. Yeah, that's right. So I think I'm right? Okay. Any other questions? Okay, so dummy variable trap is just saying that if you have 2 categories, then only use 1 dummy variable. 4 categories, 3 dummy variable. 10 categories, 9 variables, okay? All right, any other questions? Okay, if you don't have any questions, let's just call it an end, okay? It's not the end of today, but the end of this whole semester. All right, thanks for choosing QBUS5002 for the whole semester. And I hope you really enjoy your journey during your study here. And yeah, so I guess tomorrow is your final exam, right? So good luck to everyone in your final exam. And if you work hard, you will be rewarded with a very high mark, okay? So wish you all HD in your final exam. All right, that's all for today's online consultation. Thanks for watching, and hopefully I'll see you in future around campus, okay? But one thing that I'm really sad is that I don't know any of you. I can't memorize any of you. So, but anyway, if you say hi to me and talk to me, I'm used to be in your QBUS5002 class, then I will also say hi to you, okay? All right, thank you very much. Okay, enjoy your night today and have a good sleep, and all the best for your exam tomorrow and all other exams. All right, bye-bye. I'll shut down the live streaming now. 3, 2, 1, bye.